Okay, so welcome to section 6.2. 6.2 is logarithmic scales. Logarithmic scales. These are not musical scales. Okay, so let's recall. That an exponential equation, is of the form, y is equal to a to the x, right? So definition. So a logarithmic equation, that's what we're defining. So a logarithmic equation is of the form, y, actually, let me put it here, y is equal to log, log, the base of a and an x, and this is read aloud. Y is equal to 2 log base a of x. That's how we say that. Log base a of x. Okay, so I want to note something about log base a of x. So note, if I have y is equal to log base a of x, then this is equivalent to, starting down here, a, and coming over here, raised to the y is equal to, coming around here, x. So notice, if I go back up to my recall up here, y is equal to a to the x. A logarithm is x is equal to a to the y. So these are equivalent statements. These are exactly the same thing. Okay, so let's practice this. And it looks like a snail. It goes in a circle. So for example, so let's express the following in exponential form. So express the following in exponential form. Okay, so number 1, let's say we have 3 is equal to log base 2 of 8. Okay, so what I want to do is I want to start at the bottom. So I claim that this is equivalent to 2. And I'm going to raise this to the, actually let me make this more of a circle. Raise it to the 3 and set that equal to 8. And is that true? Is 2 raised to the 3rd equal to 8? It is. Okay, so these are equivalent statements. Okay, so number 2, let's give myself a bit of room. So let's say I have 2 is equal to log base 4 of 16. Okay, so I start at the base. 4, and I raise it to the answer, 2, and hopefully I end up with the argument what's inside, 16. Is 4 squared equal to 16? Yes, it is. So these are equivalent statements. Base raised to the answer is equal to the argument. So let's try another one. Let's say I have 5 is equal to log base 2 of 32. So I start down here at the base. So 2. Then I raise it to the answer, 5, and hopefully I will get what's inside the argument, 32. So actually maybe I should be putting circles around these to make it easier. So you see where I'm going with this. No, that one doesn't want to become. Okay. So, and is it is it true that 2 to the 5th power is 32? It is. It is. Okay, so let's do another one, number 4. So we have 4 is equal to log base 3 of 81. Okay, so I start at the base here at 3. I have 3, and then I raise it to the answer, which in this case is 4. So 3 to the 4th power. I hope that that's equal to what's inside, 81. Well, it is, because 3 to the 4th is the same as 9 squared. 9 squared is 81. Okay, so now let's go backwards. Now that we've changed from logarithmic to exponential form, let's go the opposite way. So for example, let's express the following in logarithmic form. So express the following in logarithmic form. Okay, so number 1, let's say I have 4 to the 3rd power is 64. Okay, so the way I do this is I always like to put my equal sign and log. I just write log because I know the base of the exponent is the same as the base of the logarithm. So 4. Then I know it's raised to the 3rd power, so that'll be what this is equal to. And set equal to the argument. So I know that this will have a 64 inside. So there we are. That's the logarithmic form of this expression or equation. So number 2, let's say I have 5 squared. Let's do 5 squared is 25. So let's change this to logarithmic form. So of course the first thing I want to set up is my equals log. Then I look at my base. My base over here is 5. So that's what I'm going to put down here. I know I raise that base to the answer, 2, and I set it equal to the argument 25. So this will be 25 inside the logarithm. So 2 is equal to log base 5 of 25. Let me make this a little bit shorter. Okay, let's do another one. To number 3, do I have enough room? Okay, so let's do 2 to the 4th is equal to 16. So I start off with equals log. And then my base is 2. I'm raising that to the answer 4. And setting that equal to the argument 16. So 4 is equal to log base 2 of 16. Okay, so let's do definition. And we have 2 definitions here. The first definition is common logarithm. Common logarithm. That's what we're defining. Denoted by y is equal to log of x has base 10. Okay. So let's see if I can bring that a little bit in. Yeah. Second part of this definition will be the natural logarithm. Natural logarithm. So the natural logarithm denoted by y is equal to ln of x has base e. Has base e. Okay, so i.e. y equals to log of x is equivalent to log base 10 of x, and y equal to ln of x is equivalent to log base e of x. That's what this means. Okay, so for example, let's estimate the value of x. So estimate the value of x in the equation. Let's do 10 to the x is equal to 70. Okay, well, let's note something before we start. Do you agree that 10 to the 0, actually, let's start with 10 to the first is 10, and 10 to the second is 100, right? So I claim that 10 to the x is 70 is somewhere in between 10 and 100, right? So whatever x is, it's in between 1 and 2. So far, so good. So x in between 1 and 2. The exponent, right? Okay, so let's start with what we were given. 10 to the x is equal to 70. Okay, well, this is equivalent to always write equals log. I know my base is 10. I'm raising it to the power of x and setting it equal to the argument 70. Agreed? Base 10 raised to the answer x is equal to log of 70. Okay, so in this case, x is actually equal to common logarithm. So this is just log of 70 because the base is 10. And that's because base equals 10. So it's a common logarithm. Okay, so what you're going to do is you're going to go to your calculator and either press log, L-O-G, and then 70, or you're going to press 70 and then L-O-G, and what you'll get is an x value of 1.845, and that is in between 1 and 2, so check mark. So that makes sense. Okay, so we estimated it up here between 1 and 2, and we were right. So for example, so let's find x in the equation. So find x in the equation. Let's do e to the x is equal to 148. Okay, so let's start with that equation. E to the x. Actually, maybe I should color code it. So e to the x is equal to 148. Because I know I can rewrite this in an equivalent logarithmic form. X is equal to log base e of 148. Okay, well, base e is natural logarithms. So I can rewrite this as x is equal to ln of 148. And that's because the base is equal to e, which is natural logarithm. Okay, so you're going to go to your calculator, and you're either going to press 148 and then ln, or you're going to press ln and then 158. It depends on your calculator. And what you're going to get is something that's approximately equal to 5. I tried to make it as close as possible. Okay, so that is it for section 6.2. That's all I'm going to do for this section. I'll see you in the next section.